Here we have another example of our proof system in action, this time introducing a trick for using existential sentences in proofs. We know that horses are faster than dogs, and we know there is at least one greyhound that is faster than every rabbit. We know that Harry's a horse and Ralph is a rabbit. Our job is to prove that Harry is faster than Ralph. First of all, we need to formalize our premises. The relevant sentences are shown here. Horses are faster than dogs. For all x, y, if x is a horse and y is a dog, then x is faster than y. There is some greyhound that can outrun every rabbit. There is a y, such that y is a greyhound. And for all z, if z is a rabbit, then y is faster than z. Greyhounds are dogs. For all x, g of x implies d of x. Outrunning, the faster than relation, is transitive. For all x, y, z, if x is faster than y, y is faster than z, then x is faster than z. And finally, Harry's a horse and Ralph is a rabbit. Note that we've added these two facts about the world not stated explicitly in the problem, namely that greyhounds are dogs and that the faster relationship is transitive. Now note this existential sentence in line 2. The trick for using such a sentence is to start a subproof, assume the scope of the existential sentence, derive a conclusion in the subproof, and then use implication introduction, universal introduction, and existential elimination to promote the conclusion to the top level. Let's see how that works in practice. On line 7, we start our subproof with an assumption corresponding to the scope of the existential on line 2. G of y and for all z, r of z implies f of y, z. Lines 8 and 9 come from and elimination applied to line 7. Line 10 is the result of applying universal elimination to the sentence in line 9. And on line 11 we use implication elimination to infer that y is faster than Ralph. Next we instantiate the sentence about greyhounds and dogs and infer that y is a dog. Then we instantiate the sentence about horses and dogs, and we use and introduction to form a conjunction matching the antecedent of this instantiated sentence. Harry is a horse and y is a dog, and we infer therefore that Harry is faster than y. Now we have y is faster than Ralph and Harry is faster than y. We're almost there. Here we instantiate the transitivity sentence for the faster than relation with 3 applications of universal elimination. We form the necessary conjunction and infer the conclusion that Harry is faster than Ralph. Unfortunately, it's still in a subproof, and we need to get it to the top level to eliminate the assumption that allowed us to produce this result. So, we use implication introduction to discharge our subproof. We use universal introduction to universalize this result. And we use existential elimination to produce our overall conclusion. The main thing to take away from this example is how we assumed the scope of the existential in the second line, then proved our results, and then used existential elimination to promote those results to the top level.